Hello my dear students, welcome to IMS Gate Academy. So I am welcoming all of you for this live session series of the previous year questions of communication system subject. So in the last session we have discussed the important questions which are asked in the year 2018, right? So after that, at the end of the session in the last class, I have given one homework question. How many of you tried that question? So at least whatever the answer you got, you can mention in the chart now. Okay, so in this particular session, I am going to discuss one gate question which is asked in the year 2018. After that, we'll discuss the selected questions which are asked in the year 2017, right? So all of you kindly share this video link with all of your friends so that they also will get benefited by attending this session in live. Okay, so this particular session is also useful for both the branches as usual, electronics and communication and instrumentation, right? So kindly share this video link quickly with all of your friends. Okay. So this is the question I have given as a homework in the last class. This is a question asked in the year 2018 for 2 marks. So whoever tried this question, you can mention your answer in the chart. Okay. Whoever couldn't attended the session live in the last class, okay, no problem at all. So currently I am giving some time for solving all of you for solving this question now. Okay, right. At least you can give a try now. Whatever the answer you are getting, you can mention the chart. Yeah, time up. So what are the answer you are getting, you can mention the chart. Okay. So first of all, read the question carefully. in this particular question they have mentioned N of t is nothing but a white Gaussian noise process. Okay, with two-sided power spectral density they have given as 0.5 watt per H. Okay, so whenever you are having units watts, that means it is related to power, and here in the denominator you are having units H, so that is nothing but the units of frequency, right? Yes, very good Manoj, very good. Okay, so that means here power divided by the frequency, that means power spectral density. Okay, so the units are watt per H. Now this power spectral density, okay, they have given as input for a filter which is having the impulse response. They have given as 0.5 into e power minus t square by 2. Okay, now at the output of filter you will get the output, right? So that output they have represented as y of t. Now regarding this particular output, they are asking the corresponding power. How much power you are getting at the output of this particular filter? That is the question, right? Here in this question, they have considered one filter which is having an impulse response h of t. For this particular filter, input is the white Gaussian noise, that is n of t, and the corresponding output they have labeled as y of t, right? So for the input noise n of t, the corresponding power spectral density S n of f, we can represent the power spectral density like S n of f, and regarding the output, the power spectral density is S y of f. Whenever you are having any filter, for that particular filter, if you are giving something as the input, some random process as the input, that time in order to find the corresponding output power spectral density, I hope all of you know this formula. Output power spectral density is equal to input power spectral density. In this case, that is regarding the noise, white noise. So Sn of f into, regarding this particular filter, they have given the impulse response h of t, right? The corresponding Fourier transform function, you will get the transfer function as capital H of f, right? So here in the formula, you will be having output power spectral density equal to input power spectral density into magnitude of h of f whole square. Okay, but here in this question they have given h of t. They haven't given h of f. If you want to calculate, you can calculate h of f by applying Fourier transform to this one. But here without finding the Fourier transform, we can easily calculate. How it is, I will explain in short. Okay, because here in this question they are not asking the power spectral density, rather they are asking the power. They are asking the power at the output, right? So power in the output, for the timing I am labeling as p suffix y. Otherwise, if you want, you can label p suffix capital Y, no problem, right? So power is nothing but, how we can get power if you know the power spectral density? By performing which operation you can get power from the power spectral density? You are having the power spectral density, that power spectral density you are going to get by using this equation, right? So what operation if you perform for this output power spectral density so that you can get the power? Any idea? I already given the hint here. Power spectral density units are what? Watt per H. But I want to get only power. So that means what we have to do? Whether we have to perform integration or differentiation for the power spectral density so that you will get power. Which operation we have to do? Manoj, any guess? what operation if you perform on the power spectral density so that we will get the power. Yes, here we want to calculate the output power, but we are having the power spectral density, right? So we have to perform integration. Whenever you are performing integration is nothing but area under the curve, right? So here integral limits minus infinity to infinity, output power spectral density, that is Sy of f into df. If you perform the integration of the power spectral density, from there you are going to get the power. Okay, right. Now you can substitute this entire equation here. Whatever you are having RHS, you can substitute here. So power at the output is equal to integral minus infinity to infinity Sy of f is nothing but Sn of f magnitude of h of f whole square, right? Yes, very good Manoj, very good. Sn of f into magnitude of h of f whole square df. So according to the given question, the power spectral density of the white noise they already mentioned, that is 0.5 watt per h. 0.5 watt per h. Integral minus infinity to infinity. So regarding this one already they have given, that is 0.5. 0.5. So and then you are having magnitude of h of f whole square df. Here 0.5 is a constant, so we can keep outside the integral. Integral minus infinity to infinity magnitude of h of f whole square df. Now this equation you are having in terms of frequency domain, right? So this equation we can convert into time domain. Okay, we can write like this by using Parseval's relation. I hope all of you know, when you have studied regarding Fourier transform properties, Parseval's relation you might have studied, right? So whenever you are having integral minus infinity to infinity magnitude of h of f whole square df, this one we can write in terms of time domain. Integral minus infinity to infinity h of t whole square dt. Magnitude of h of t whole square dt. Okay, that is the reason I have mentioned in this particular question they have given only impulse response. Okay, so if they are asking to calculate output power spectral density, definitely you have to apply Fourier transform. But here they are asking the output power, so for that we have to perform integration. So in that process, regarding the input power spectral density, it is a constant, so we kept outside the integral. After that you are getting the relation like this. Whenever you are getting the relation like this, you can represent in the time domain like this by using Parseval's relation, right? Now you can substitute whatever h of t they have given in the question. So 0.5 I am keeping as it is, integral minus infinity to infinity h of t. H of t they have given 0.5 into e power minus t square by 2. 0.5 into e power minus t square divided by 2. This overall term you are having the square dt. H of t whole square dt. H of t in the question given as 0.5 into e power minus t square by 2. I have substituted. Okay, I hope it is clear for everyone up to this step. Now just perform square of this overall term. What you are going to get? 0.5 I am keeping as it is. Now 0.5 whole square. 0.5 whole square, that is nothing but 0.25. 0.25. Integral limits you can keep as it is. Minus infinity to infinity. Now can you tell the square of this term? E power minus t square by 2 whole square. How much you are going to get? All of you quickly respond. It is like a power m whole power n, so we can write it as a power mn, right? So that time 2 will get cancelled, right? So you are getting simply e power minus t square, e power minus t square. I hope it is clear for everyone. 0.5 whole square is 0.25, e power minus t square by 2 whole square, both here 2 is in the numerator, here 2 is in the denominator, right? Both will get cancelled. You are getting simply e power minus t square. Okay. So here 0.25 is nothing but 1 by 4 and 0.5 is nothing but 1 by 2. So together you can write 1 by 4 into 1 by 2, that is nothing but 1 by 8. Okay. And then integral minus infinity to infinity e power minus t square dt. E power minus t square dt. So here for the timing, let us assume t square equal to x. Okay, I am assuming t square as x. Then just perform differentiation both sides. So you will get 2t dt is equal to dx. Here we are having the term dt. So from here we will get dt as dx divided by this 2 times dt. You can bring to the right hand side. It will come into the denominator, right? 2t. Okay. So here t square I have assumed as x. Okay. So that means whatever the integration here you are having in terms of t, but now I am converting into some other variable x, right? So in place of t square we can substitute x. Now in place of dt we can write dx by 2t. So that means still t term is there. So from here t we can write it as, if you perform square root on both sides, you will get simply t here. Here on the right hand side you are going to get root x. Now in place of t you can substitute root x, so that you are getting the overall integral term in terms of x, right? So from here you are going to get dx divided by 2 into root x. 2 into root x. Okay. Now, so before this I am writing one more step. Okay. Whatever the procedure we have followed, this entire thing is same as it is, but here I am just applying one property. Here e power minus t square, is it even function or odd function? All of you please respond. E power minus t square, this function, is it even function or odd function? See, in place of t, if you are putting minus t, what is the function you are going to get? Yes, minus t whole square is nothing but t square. That means you are getting same function, right? So that means it is even function. So whenever you are getting even function, if you are performing integration for both the sides, that means negative time axis and positive time axis, that means we can represent this overall limit from minus infinity to plus infinity. Yes, very good Manoj, very good. So we can represent this overall integral limits into like this. 1 by 8 we can keep as it is. 1 by 8 we can keep as it is. This overall integration we can represent only for the positive limits. That means we can represent like 2 times integral 0 to infinity e power minus t square dt. E power minus t square dt. Yes, very good Manoj, very good. So here 2 4 times. Okay. Suppose if this function is odd, that time when you are performing integration, you are going to get 0. Since this function is even, we can represent this overall integration into like 2 times integral 0 to infinity e power minus t square dt. Now after this t square equal to x, this procedure as it is. Okay, right. Now you can substitute. In place of t square x, in place of dt you can substitute this one. Now can you guess what are the limits you are going to get with respect to x? with respect to x. So here py is equal to 1 by 4 integral. Limits will be what? Whether it will be 0 to infinity only or whether it will change. So you can substitute here in place of t, substitute the lower limit. 0 square is nothing but 0. So that means x value is also 0. Similarly, in place of t, substitute the upper limit, infinity square, that means obviously infinite, very large value. So x value become infinity. So that means whatever the limits you are having for t, same limits you are going to get for x as well, right? So here 1 by 4 integral 0 to infinity e power minus x into dt is nothing but dx by 2 times root x. Yes, very good Manoj, very good. Dx by 2 times root x. Okay, so here 4 and 2 are in the denominator, so we can multiply. 4 2s are 8. Integral 0 to infinity e power minus x. Here in the denominator you are having root x. Okay, so for the timing I am writing that one as x power 1 by 2. Square root is nothing but what? It is having the power 1 by 2. Suppose if it is a cube root, power 1 by 3, like that. So 1 by 8 we can keep as it is. Integral 0 to infinity e power minus x. Okay, now in the denominator you are having x power 1 by 2. I am bringing into the numerator. Then it will become x power minus half. Whatever the power here you are having, when you are bringing into the numerator, it will change the sign. Okay, x power minus half. So how to simplify this particular integration? Which method you have followed, Manoj? By using which function you have solved this question? I hope you have studied one of the function in the mathematics. Okay, with the help of that function, you can solve whenever you are getting the integration terms like this. You might have studied in the mathematics. By using that function, you can easily solve this particular question. Can you recall which function we have to apply here? Yes, yeah, we can use gamma function. With the help of gamma function, you can easily get. Okay, of course, you can use another methods which you might have studied while you are simplifying the integration. Okay, while you are doing the problems related to integration, you might have studied other methods also. So one of the function is gamma function. With the help of that function, you can easily get. Okay, so first of all, I am writing the gamma function here. Gamma function. Gamma of, say for example, I am considering it is a function of n, right? So integral limits are 0 to infinity e power minus x into x power n minus 1 dx. E power minus x into x power n minus 1 dx. Okay, whenever you are having integration, whenever you are performing, that time if you are having exponential term and algebraic term, especially when it is in the power of x, okay, try to represent in this function. Okay, this overall function you can write it as gamma of n. Now here if you observe e power minus x, it is exactly matching. E power minus x matching. Integral limits also matching 0 to infinity. Here you are having x power minus half, but here you are having x power n minus 1. Okay, so somehow or other we have to adjust this one into which form? In the base you are having x, there is no problem. Okay, regarding minus half, we have to write in the form like n minus 1. in the form n minus 1. Yes, very good Manoj, very good. So here I am keeping 1 by 8 as it is, integral 0 to infinity e power minus x into x power this minus 1 by 2, I am writing like this. See, minus 1 by 2 is nothing but what? Minus 0.5. Okay, so that means 1 by 2 is nothing but 0.5. So 0.5 minus 1 is nothing but minus 0.5. Both are same only. Because here we have to represent in the order of n minus 1, right? Yes, very good Manoj, very good. So 1 by 2 minus 1 dx. Now exactly it is matching. E power minus x into x power n minus 1. Here n is nothing but 1 by 2. N is nothing but 1 by 2. So 1 by 8 I am keeping as it is, gamma function 1 by 2. Gamma 1 by 2 is nothing but root pi, right? So root pi divided by 8. All of you do the calculation. You will get 0.22. 0.22. 0.22 is the correct answer for this question. I have applied the gamma function here. So here if you observe, while solving this question, you should have the knowledge of signals and system concepts and you should have the knowledge of mathematics concepts, right? So whenever you are having advanced subjects, okay, so for solving some of the questions, definitely the concepts of that respective subject definitely required. In addition to that, for solving the problem of that particular question, you require the concepts knowledge of the other subjects as well, right? So that's why if you are strong on the basic subjects, okay, then definitely you can easily solve the questions of the advanced subjects. Otherwise, you may face the difficulty, right? So if you want to become master in the advanced subjects, so first of all, you should become strong on the basic subjects, okay, right? So for this question, option B is the correct answer. Option B is the correct answer, right? So I hope it is clear for everyone. So now let us move on to the questions which are asked in the year 2017, right? So all of you give a try. I will give some time. This is the easy question. I hope all of you can get the correct answer for this question. Manoj, you can cross check once again. Still we are having time. You can just give a try once again. Yeah, time up. Okay, I will explain now. Yeah, first of all, let us read the question. Yes, very good, Manoj, very good. So here they have given the random process x of t as u plus vt, where u is a zero mean Gaussian random variable. Okay, it is a Gaussian random variable which is having the mean value 0. Whereas regarding v, they have mentioned it is also random variable, but it is a uniformly distributed random variable in the interval 0 to 2. Okay, in the interval 0 to 2, its value is the constant. That is the reason they have mentioned it as the uniformly distributed random variable. Okay, assume that u and v are statistically independent. Now the question is, the mean value of the random process at t equal to 2 is dash. Okay, right. So first of all, let us consider the random process given x of t equal to u plus vt. The given random process is x of t equal to u plus vt. Now the question is at t equal to 2, right? So substitute t equal to 2. At t equal to 2, this equation becomes x of 2 is equal to u as it is v into 2. So for the timing, I am writing it as 2 times v. Both are same. Okay. So in this question, they are asking the expectation of the random process at t equal to 2. So we can use the expectation operator, right? So expectation of x of 2 is equal to expectation of this overall term. Expectation of u plus 2 times v. So we know that expectation operator is the linear operator, right? Just like when you are performing like integration, okay? So that time if you are having two terms sum together, okay? So we can perform individual integration. After that we can add, right? In the similar way, here expectation operator is a linear operator. We can perform individual expectation. After that we can perform the algebraic sum. Okay, right. So that means here we can write expectation of u plus expectation of 2 times v. Expectation of 2 times v. So according to the given question, what is the expectation of u? Already they have given the value in the question. If you have carefully read the question, u is a zero mean Gaussian random variable, right? Zero mean Gaussian random variable. So that means mean value already they have given regarding u, that is 0, right? Mean value is 0. Okay, expectation of u is 0. See, whenever you are performing expectation of random variable, that is nothing but simply mean value, right? So that value already they have given in the question, that is 0. Now, yes, very good, Manoj, very good. Here you are having expectation of 2 times v. So here 2 is the constant. So we can keep outside. So 2 times expectation of v. So regarding random variable v, they haven't directly mentioned the mean value, but they have given the clue. What clue they have given? They have given the clue as regarding the random variable v, they have mentioned it is the uniformly distributed in the interval 0 to 2. Okay. Okay, so here between 0 to 2, here between 0 to 2, sorry, from 0 to 2, right? Okay. So between 0 to 2, it is uniform. So the distribution function or density function, it is a constant, right? Okay, so here mean value we have to calculate. Yes, very good, Manoj. See, mean value means it is very simple. So you have to consider a point on the v-axis in such a way that this particular probability density function should be symmetrical. Okay, say for example here this particular probability density function you are having constant in the interval 0 to 2 for uniformly distributed random variable. Okay, so say for example this one is A, this one is B. Okay, so the mean value is nothing but just you have to take average of these two, that's all. A plus B divided by 2. A plus B divided by 2. So according to this question, A is nothing but 0, B is nothing but 2. 0 plus 2 divided by 2. So that means you are getting 2 by 2, which is nothing but 1. So here if you are considering the mean value as 1, so when you have considered V value as 1, with respect to that, if you just observe left hand side and right hand side, both the whatever the density function you are having, it is a symmetrical with respect to this line, right? So that whichever point, with respect to whichever point the density function is symmetrical, right? So that particular point is nothing but mean value. Okay, right. So here as of now we got the mean value as for the random variable V as 1. Now you can substitute, that's all. So 2 into 1, that is nothing but 2. So in this question, regarding the U, they have already given the mean value. Whereas regarding random variable V, they haven't given the mean value, but they have given the clue, that is that particular random variable is uniformly distributed, right? So now tell me, how many of you actually for solving this question, whether do we require pen and paper? All of you please respond. In order to get the answer to, final answer to, whether do we require really pen and paper for solving this question? Not required, right? So that much dead easy question. Okay, so in this way some questions you will get, okay, whatever the calculation is there, that calculation you can do in the mind only, right? Whatever the simple calculations, in the last class also we have discussed some, whenever you are getting simple calculations, simple formula based questions, try to do that calculation without using pen and paper so that you can answer the questions in less time. Okay, so if you are able to attempt a few questions in less time, definitely whatever the amount of time you have saved, that time you can spend for, definitely few questions will be there. It may take more time for solving such kind of questions, for understanding the question, or even for solving the question, right? So that time you can invest that whatever the saved time earlier, that time you can use for those kind of questions. In that way you can well balanced and you can optimum number of questions you can efficiently you can attempt, right, during your GATE exam time within the 3 hours time. Okay, you should be very smart which questions you have to attempt first, which questions you have to attempt at the middle, which questions you have to attempt at last. Otherwise what will happen, you may be having very good questions which you know the answers correctly, but those questions are left, okay, at last present, but due to time management, mismanagement of the time, okay, due to lack of time properly management, you may miss those kind of questions, right? So that's why whenever you are attempting any competitive exams like GATE, time is a crucial thing. So first of all, focus on the accuracy while you are learning any subject. Focus on the accuracy. Once if you are good at getting correct answers, okay, then focus on the speed, okay, so that you can get very good number of, you can attempt very good number of questions correctly in less time, right? Because in the competitive exams like GATE, two things are important. One is accuracy, another one is speed. Okay, right. So for this question, the final answer is 2. Okay, right. Now I will show the next question. All of you give a try. This is a question based on signal to quantization noise ratio related to the pulse code modulation concept.
you have to give value, sir.
Yeah, time up. Any guess? What is the answer for this question? Okay, so meanwhile you can mention what is the answer you are getting. Okay, first let us read this question. You are having a sinusoidal message signal. It is converted to a PCM signal using a uniform quantizer. The required signal to quantization noise ratio at the output of quantizer, they have mentioned this is the minimum requirement 40 dB. 40 dB. Now the question is the minimum number of bits per sample. For each sample, how many minimum bits we can use in order to get the desired SQNR as 40 dB? That is the question. Okay, so whenever you are having signal to quantization noise ratio in the order of decibels, I hope all of you remember the standard formula, right? So first of all, I am writing the SQNR in dB. Signal to quantization noise ratio in dB, decibels, is nothing but 1.8 plus 6n. 1.8 plus 6n, where n is nothing but number of bits required for each sample. Okay, so say for example, I am making the tabular form. So here I am considering n and here I am considering SQNR in the order of decibels. SQNR in dB. Okay, so you can start from n value 1, 2 like that. Okay, but for the timing I am considering n value 5. N value 5. So here 1.8 is constant, we can keep as it is. 6 into 5. 6 into 5. So 6 5s are 30 plus 1.8, that is nothing but 31.8. 31.8. Okay, but here what is our requirement? Our requirement is 40 dB. Okay, so if you are using 5 bits, we can achieve the signal to quantization noise ratio as 31.8, but our requirement is 40 dB. So that means 5 bits are not sufficient, right? So let us increase one more bit. I am considering 6 bits. Okay, in this case, same equation you can use. 1.8 plus 6 into, in place of n, you can substitute 6. So 6 6 are 36 plus 1.8 is nothing but 37.8. So if you are using 6 bits, we are able to get SQNR as 37.8. Now tell me whether 6 bits are sufficient, or not in order to get our desired SQNR 40 dB. All of you quickly respond whether 6 bits are sufficient or not. Here with the help of 6 bits we are able to get 37.8 dB regarding SQNR, but our requirement is 40 dB. Obviously no, right? Because our requirement is 40 dB, but we are able to get only 37.8, right? So 6 bits are not sufficient. Then go for next bit. I am considering 7th bit, one more bit. Okay, so here 1.8 as it is plus 6 into n is nothing but in this case 7. So 6 7s are 42 plus 1.8, that is nothing but 43.8. 43.8. So if you are using 7 bits, we are able to get SQNR as 43.8 dB. Okay, so here our requirement is 40 dB. Yes, we are able to achieve. Okay, so with the help of 5 bits we are able to get only 31.8. If with the help of 6 bits we are able to get only 37.8, whereas with the help of 7 bits we are able to get up to 43.8, but in this question the requirement regarding SQNR is 40 dB. So obviously 40 dB we cannot able to get with the help of 6 bits. So obviously we have to consider 7th bit also, right? So here the question is the minimum number of bits per sample in order to get the minimum signal to quantization noise ratio as 40 dB, right? So in order to get the desired SQNR for this question, the final answer is 7. Final answer is 7. Okay. See here, for understanding purpose, for each case I substituted and I found the equivalent values or final values. But here if you carefully observe, regarding SQNR in dB, in this entire equation, here only n is the variable. Yes or no? Only n is the variable. Here 1.8 is a constant, 6 is also constant. Only n is the variable. Okay. So that means, say for example, when you have considered 5 bits, that time you got, say for example, with the help of 5 bits you calculated the corresponding SQNR as 31.8, right? Now once if you know this value for 5 bits, just if you are increasing one bit, see obviously this 1.8 is constant. Here what is happening? 6 into 1 is nothing but 6. That means from here I have increased one bit, right? So that means from here 31.8 plus 6 dB is nothing but 37.8. 31.8, just by increasing one bit the SQNR is getting increased by 6 decibels. Okay, you are getting this one. Next, similarly from here if you are increasing one more bit, so here whatever the value you got, now you can add 6 dB. So from here you are going to get this one. 37 plus 6 is nothing but 43. In this way you can do the calculation easy. Okay, and sometimes you will get like this variety of questions also. For every 1 bit increase, okay, the resultant SQNR is getting increased by 6 dB. Okay, they can give in the answers, okay, how much dB it is going to increase. Okay, right. Okay, I will show the next question. This is a question asked in GATE EC in the year 2017, set 2 for 1 mark. This is a question related to information theory concept regarding the binary symmetric channel. So all of you read the question and try to choose the correct option. Yes, very good Manoj, very good, correct answer. So in this particular question, they have mentioned one important keyword. What they have mentioned? Binary symmetric channel. Binary symmetric channel. Okay. With crossover probability P. So that means when you are transmitting 0, okay, ideally you should receive 0. But at the receiver, 0 becoming 1. And similarly, when you are transmitting 1, you should receive 1. But due to some error, okay, instead of receiving 1, you may receive 0. Okay. In order to, whenever you are transmitting any bit, ideally you should receive the same bit, but instead of that, if you are getting opposite bit, okay. So in order to get like that, the corresponding probability they have mentioned, it is P. It is P. Now in this question, they are asking regarding the capacity, channel capacity. Okay. So regarding that, they have given the waveforms or diagrams here, right? You have to choose the correct one. Regarding binary symmetric channel, I hope all of you know the formula regarding the channel capacity. For binary symmetric channel, the channel capacity, the formula is 1 plus P into log P base 2 plus 1 minus P log 1 minus P base 2. This is the formula for channel capacity for the binary symmetric channel. Okay. Say for example, when you consider, okay, so here I am making one tabular form. So here I am considering probability value, crossover probability P, and here I am calculating the resultant channel capacity. Say for example, when you consider P value 0, just substitute here in this entire equation, wherever P is there, just substitute 0. Here constant 1 you can keep as it is. Now 0 into anything, you will get 0. Now here 1 minus 0 is nothing but 1, log 1 is nothing but 0. So finally you are going to get 1. Okay, channel capacity you are going to get 1. If the crossover probability is 0, that time you are getting channel capacity as 1. Okay. Now let us consider P value as 0.5. P value as 0.5. Substitute here, wherever P is there, substitute 0.5. 1 as it is. For the timing, 0.5 we can write as 1 by 2. 1 by 2. So here in place of P I am writing 1 by 2 log, in place of P once again 1 by 2 base 2. Here 1 minus half log, once again this term 1 minus half base 2, right? So here 1 as it is, 1 by 2 log 1 by 2 we can write it as, okay, for the timing I am keeping like that. In the next step I will write log, this term I have copied as it is, 1 by 2 log 1 by 2 base 2. 1 minus half is nothing but half. Once again this one is half, so half log half base 2. So this term both are same, right? So you can consider this term and multiply with 2. So from here you will get 2 times this term. That means 1 by 2 log 1 by 2 base 2. So here 2 will get cancelled. 1 by 2 you can write as 2 power minus 1. 2 power minus 1. So that means log 2 power minus 1 base 2. So this expression you can write as 1 I am copying as it is minus log 2 base 2. Can you guess what is the resultant value you are going to get here? 1 minus log 2 base 2. How much? I hope all of you will get the correct answer. All of you please give a try. What is the value for that one? Similarly, all of you give a try. When you are considering probability as 1, what is the resultant channel capacity you are going to get? Yes, it is very simple, right? Log 2 base 2 is how much? 1. So 1 minus 1 is nothing but 0. 1 minus 1 is nothing but 0. When the crossover probability like 0 becomes 1 or 1 becomes 0, if you are having the crossover probability is 0.5, that time your channel capacity is 0. Okay. Now let us consider the crossover probability as 1. Yes, very good Manoj, very good. Here in this case 1 I am keeping as it is. In place of p substitute 1. Log 1 is nothing but 0. Log 1 is nothing but 0. Here 1 minus 1 is nothing but 0. So that means you are going to get 1. You are going to get 1. Okay, right. So what is your observation? So in this way, if you want, you can consider more number of probabilities in between 0 to 1, because here probability, P stands for crossover probability. Obviously the probability value can lies between 0 and 1, right? So within 0 to 1, according to your requirement, you can consider more number of values. But for the time being, I have considered the starting probability, ending probability, and in between intermediate probability. So for each probability, I have calculated the corresponding channel capacity. Now with this understanding, when you look at the probability value 0, that time you are getting channel capacity as 1. When you are having probability as 1, that time also the channel capacity you are going to get 1. Okay, with the help of these two observations, if you look at the options, when you are having probability 0, when you are having probability 1, that time you are getting 1 channel capacity. Okay, here probability 0, channel capacity 1. Here probability 0, channel capacity 1. Similarly, probability 1, channel capacity 1. Probability 1, channel capacity 1. Okay, this waveform is exactly opposite to this one. This diagram is exactly opposite to this one, right? So with this understanding, we can eliminate option B and option D. Option B, option D we can eliminate. Okay, right. So here, now let us observe the other option. Like when you have considered probability as 0.5, that time you are getting channel capacity as 0. Channel capacity as 0. Yes, here also you are getting 0, here also you are getting 0. Okay, but if you closely observe these two waveforms, it is a straight line fashion, but it is a smoothly varying waveform. It is a curvature. Okay, now among these two, which one we have to decide? Which one is really correct? Okay, see here in this entire equation, do we have straight line equation format? No, right? We don't have straight line equation format. We are having this equation in the, it is in the function of logarithm. Whenever you are having log or exponential, it is a smoothly varying waveform, right? It is not the straight line function. It is not the straight line function. So that is the reason we have to eliminate option A. Obviously, option C is left over. That will be correct answer. I hope it is clear. So for this question, option C is the correct answer. See, with the help of first two observations, we are able to eliminate B and D. But whatever the tabular form here we have considered, for this tabular form, both option A, option C, both are satisfying. But among these two, which one we have to consider based on this particular equation? If you are having straight line equation, we could have considered this one, but we don't have straight line equation. So whenever logarithm or exponential is there, you will be having smoothly varying waveform like this. Okay, right. So that is the reason option C. Option C is the correct answer for this question. Okay, right. So this is the homework question. For the timing, I am not solving this question. All of you take the screenshot of this question. This is the homework question. Okay, all of you take the screenshot of this question and you can give it a try. Okay, what are the answer you are getting later you can mention in the comment section of this video. Okay, right. So in this particular session, we have discussed one of the gate question which is asked in the year 2018, and then we have discussed the selected questions of the selected gate questions which are asked in the year 2017, and this question I am giving as a homework. Just like in the last class, I have given one last question as a homework. Similarly, this question, this is also simple question, but for the timing I am giving this one as a homework. So all of you give it a try. Okay, so in the upcoming weeks we are having regarding the previous year questions of communication system subject. So these are the timetable. So all of you kindly take the screenshot and make a note So our regular sessions will be as usual from 3 to 4 only. Only today's session we are having 2 to 3. Okay, right. So on 16th November, 17th November, and then 22, 23. Okay. So in the upcoming sessions, okay, one session I will focus on one of the gate year. Okay. So in the upcoming sessions we are focusing on gate 2016, 15, 14, and then 13. Right. So still you're having lot of time. So whenever you get time, whatever the homework question I have given, so kindly practice, give a try, and whatever the answer you're getting, you can mention in the comment section, right? Okay, so we'll meet you all in the next session on 16th November. Okay, so thank you everyone. I hope all of you learned a lot. Whatever the series of lectures regarding communication system subject we are discussing here, right? I hope all of you are getting good confidence, good command over the subject, right? So definitely whatever the gate questions we are discussing in this series, okay, definitely it is giving a value addition in your gate preparation, right? So kindly share this video link with all of your friends so that they also will attend these sessions based on the possibility they can attend in live, and due to any reason if not possible they can watch the recorded lectures as well. Yeah. Yes, Manoj, you have shared the answer, but for the timing, I am keeping as suspense. Okay, no issue at all. Okay, we'll meet you all in the upcoming session, that is on 16th November. That time I will disclose the answer. Okay, right. Thank you everyone. We'll meet you all in the next session.